So this question is using some trigonometry modelling. So we have the wave that we're shown in the graph on the paper, and we have to try and find what the function is that matches that wave. So we know that whenever we see some sort of what we call sinusoidal, so this wave that goes up and down, then it's going to be some sort of equation around sine x. So this is kind of what we're starting with, and we're going to manipulate or transform sine x so that it actually fits the graph that I'm shown. So there are a few key things that we need to know before we start. One of them is what is the kind of central value of the curve. So you can see here that the central value is still at 0. Okay, so this is still at 0. We also need to know what the amplitude is, or how far up and how far down the wave travels. And we can see here that it travels up as far as 3, and it also travels down as far as -3. So that means that the amplitude is going to equal 3. And we're also interested in the wavelength. So if we take two values, we could either take these two here, for example, and we could find the distance between them, which is 180. You could also take these two values here and find the distance between them. You could take these two here. So you can take it anywhere, but you're interested in one complete curve, okay? And we can see there that this is one complete curve, so we've measured this. Or this is one complete curve, and then we can do the same again and so on, and we can measure the distance. So this tells us that the period or the wavelength is equal to 180. Now that we have that information, we can do our sine modelling. So the equation is going to be y is equal to, and the first thing is the amplitude. We need to stretch the sine curve, and we know that the amplitude is 3. So that means that sine x and then 3 sine x is going to go 3 times taller compared to the original. Okay, now we don't just want sine x, we know that we also have to change it a little bit more. It is along the axis of 0, that's the midpoint, so that means that there is a +0 on the end, okay? But we also need to use the wavelength, okay? This graph is a wavelength of 180. Normally the sine curve is a wavelength of 360, so ours is going twice as fast, okay? And therefore we need to alter the sine function with that, and that's done by doing 360 divided by the wavelength, which is 180. Okay, oops, we need our x value in there. So when you're doing any sort of sine modelling, it's always y is equal to the amplitude, sine of, and then it's 360 divided by the period of x plus, and then it's whatever your kind of midpoint is, okay? And that's how you will do any sort of sine or trigonometric modelling. So our first equation we can see there, and we can simplify that, which is y is equal to 3 sine, and we can simplify that to 2x plus 0. Now we know that we don't actually need to write the +0, okay? If you have got it written, then that's fine as well, but you don't need it written. And that was worth 4 marks, so that's for each part of the modelling. So 1 is for the 3, 1 is for the sine, 1 is for the 2x, and 1 is for the +0, or the fact that you've left it blank and you don't have any other plus or minus value on there. So that's question A. And then question B, this time you're told that the pitch of the sound is increased, and therefore the period is halved. Okay, so this time the period is only half of 180, and therefore it is 90. And the amplitude, it has stayed the same. Okay, so the amplitude is still equal to 3, and nothing else has changed. Therefore, we're still using sine and we still have the plus 0 at the end. So this time we have y is equal to 3 sine, and it's 360 divided by 90 of x, and then plus 0. So when we simplify that, it's 3 sine of 4x plus 0, or we just leave it as it is. The other way to do that is if it's going twice as fast, you know that this value here is going to be multiplied by 2. So instead of 2x in the bracket, you then have 4x. So this one is worth 2 marks. There is 1 mark for the 3, and there is 1 mark for the 4x. So 1 for keeping the amplitude as 3, and 1 for knowing that the wavelength has changed it to be 4x inside the brackets.